Lesson 2 of Chapter 1 is on analyzing graphs of functions and relations. So we've been discussing a definition of a function, and we're going to expand on that using graphs. So the first thing I want to discuss is when you have an input, locating the output. So you can see here's a graph, and if we were to take, for instance, an input of 1, we would start at the origin, we would go to the right until we get to the input of 1, then we'd go up or down until we hit the graph, like you can see I'm doing right now, and then when we come back to the y-axis to see what the output is. Let's suppose that that was a height of 5. So we'd say that f of 1 equals 5, and that means the input is 1 and the output is 5. Here's another one. If I gave you negative 2, we'd start at the origin right here, we'd go to the left until we get to negative 2, we'd go up or down until we hit the graph, then we'd come back to the y-axis to see what height we're at. Let's suppose that that height is negative 4. So then we would say that f of negative 2 is equal to negative 4. And this means that negative 2 is the input, negative 4 is the output. So the first example I want to go over is given a graph such as this one. This shows the internet ad revenue per year, and it's total revenue in millions of dollars, as you can see on the y-axis. And this is representing years since 1998. So part A says use the graph to estimate the total internet advertising revenue in the year 2007. Confirm the estimate algebraically. We're not going to be confirming it algebraically, we're just going to be using the graph. So, the year 2007, you have to read these graphs carefully now. If it says years since 1998, year 1 would be 1999, year 2 would be 2000, this would be 2001, 2, 3, 4, 5, 6, 2007. So if we go to 2007, we go up until we hit the graph, go over, and it looks like it's at a height of about 3,400. Now, unfortunately, that answer would be marked incorrect because you need to label. And so the proper labeling for this problem would be 3,400 million dollars. Another way of answering that would be to say 3.4 billion dollars. So either one of those answers would work. Now if you go to part B, it says use the graph to estimate the year in which the total internet advertising revenue reached 2 billion. Confirm the estimate algebraically. We're not going to be confirming it algebraically. We're just using the graphical part of it. So if we locate $2 billion on the y-axis and we go until we hit the graph, and we figure out that that is the year 2004. So that's analyzing graphs and interpreting graphs. The next thing I want to go over is domain and range. And we've talked about domain and range, but we're going to have it presented to you a little bit different. Instead of given an equation, you're going to be given a graph like you can see on this one. You're going to be asked to find the domain and range. The domain is the collection of inputs, the range is the collection of outputs. One of the things to remember is that the domain is your x values, and the range is your y values. So if we look at this graph, if we're going to come up with the domain, we ask ourselves, is there a furthest point to the left? And that answer is yes. The furthest point to the left is negative 8. Is there a furthest point to the right? And the answer to that is no, because of this arrow. This arrow means it's going to continue to go up and it's going to continue to move to the right. So because of that, there is no furthest point to the right. However, if you look closely at this area, that shows that there's a break in the graph. There's a hole. And so we need to show that break in our domain. So if we go from negative 8 to negative 4, and then union that from negative 4 to infinity, that shows the proper domain for a problem like this. Again, the difference between a bracket and a parenthesis is the parenthesis indicates that it cannot be equal to that value. The bracket indicates that it can be equal to that value. Now for the range is the y value. So you have to ask yourself, is there a lowest point to this graph? And there is. and that lowest point is negative 10. Then you have to ask yourself if there's a highest point to this graph. There is not a highest point to this graph, and everything above negative 2 at some point is defined, so that's why it's negative 10 to infinity, representing all the collection of y values. Here's a different graph, same type of problem. Use the graph to determine the domain and range. So when we find the domain, that's the collection of x values. You can see the furthest point to the left is negative 2, and the furthest point to the right is 6. Notice that I'm using a bracket on the closed circle, a parenthesis on the open circle. And now for the range, the lowest point is at 0, and the highest point is at 4. And I'm using brackets on both of those because it is defined for a height of 0 at x equals negative 2, and it's defined at a height of 4 at x equals positive 2. Next graph, same type of problem, determine the domain. Now this graph is broken apart, so this one gets done a little bit differently. But as far as the domain goes, there is a furthest point to the left. It almost reaches negative 4, but not quite. That's why I put a parenthesis on the negative 4. And then it stays at that height until you get to positive 2. You use a parenthesis on that. It's broken apart, and then it picks up again at positive 2, and it goes forever to the right. So there's your description of the domain. And again, these are x values that I'm using. The range value now, there is not a lowest point to this graph, so I'm going to start with negative infinity until you get to a height of negative 2. And then it's broken apart, and then it also has some values that are at the height of 6. Now it just stays at the height of 6, so that's why I'm just going to use a bracket around the value of 6 because it doesn't increase or decrease in this area right here. It just stays at 6. So there's your range. It's a collection of outputs. Next thing I want to do is move on to example 3 and talk about finding y-intercepts. And so if you're given an equation or a graph, and if you need to find a y-intercept, easiest way to do it is to use the equation and put 0 in for x. If you put 0 in for x, it would produce 4/3 for a y value. Now if you look at the graph should show that, and this coordinate point right here, it does appear to be at 0, 4/3. So the graph and the algebraic numeric answer are making sense. On part B, you can see that the y-intercept appears to be right here. If we put 0 in for x, we would get the absolute value of negative 5, which is positive 5, minus 1 gives us a y-intercept of 4. So put 0 into the equation, you get 4 for an output. So finding y-intercepts is pretty simple. Again, that's done by putting 0 in for x. And now we're going to talk about taking an equation and finding zeros. Zeros are x-intercepts. Well, you can look at this graph and you can tell that the x-intercept appears to be at about negative 3, and then, I don't know, 2.5 maybe. But we're going to find them algebraically. And we do that by taking this equation, 2x squared plus x minus 15, setting it equal to 0, and then solving that. So I'm going to factor this by taking the 2 and sending it to the back. And that would give me x squared plus x minus 30. Now I can factor this into x plus 6 and x minus 5. And I divide both of these by 2 because I sent the 2 to the back, so that gives us x plus 3 and 2x minus 5. So that produces x-intercepts of negative 3 and 2.5. So again, to find zeros algebraically, you put a 0 in for y and then solve. Here's another one. The equation, this time, we've got 3x to the third minus 10x squared plus 8x. And so this time we can factor an x out of everything, leaving me with a 3x squared minus 10x plus 8. And so now I'm going to factor that. And you could take the 3 and send it to the back, but I'm going to do it just a little bit faster using number sense. I'm going to put a 3x and a 1x at the beginning. I'm going to choose a negative 2 and a negative 4 for my two factors. And so this is factored correctly, and how I know that is because the outside terms give us negative 6x, the inside terms give us negative 4x, and that combines to give us the negative 10x. Therefore, our zeros are 2, 4/3, and 0. And if we look at the graph, we should see 3 x-intercepts at approximately those areas, and it does match up. Here is one more, finding the 0 algebraically. This time it's a square root graph. So if we put 0 in for y, we get 0 equals the square root of 4t plus 1. And so what I would do now is I'd square both sides to get rid of that square root. And in doing so, the square root and the square cancel. So we're left with 0 equals 4t plus 1. We subtract 1 and divide by 4. We get negative 1/4 equals t. This represents our 0, or our x-intercept. And if we look at the graph, certainly this point right here appears to be negative 1/4. So that's finding zeros, y-intercepts, and also determining domain and range and analyzing graphs of functions.